Hi, I'm Bob. Welcome to the Stata course about summary statistics and regression analysis. When we see a continuous variable, we usually want to know its distribution, whether it is normally distributed or whether it is right or left skewed. Today, we will look at various Stata commands that analyze a continuous variable's distribution, including summarize, inspect, sktest, and histogram. We continue to use the BOB.dta data file for this topic. Please download the dataset from the resource link. The do file for this topic is also provided. Suppose the dataset is placed in the current working directory. We load the data by typing use, followed by the dataset's name. We use the Stata command described to look at the information of the dataset. Suppose we are interested in one of the continuous variable, the hourly wage, hwage. We use the Stata command summarize to find summary statistics of the variable by typing summarize hwage. Here we can see that the hourly wage in this sample has a mean of around $22.04 and a standard deviation of about $14, with a relatively high maximum value of $80. We can use the detail option to obtain more information. The percentiles tells us the value of each percentile. The 50 percentile, which is also known as the median, is $18.75. Skewness and kurtosis are the two statistics of distribution. Skewness is the measure of the symmetry of a distribution. A skewed distribution occurs when one tail is longer than the other. A right-skewed distribution occurs when the long tail is on the right side of the distribution, as shown in the graph. The mean is sensitive to extreme values. The long tail on the right pulls the mean away to the right. As a result, the mean is greater than the median. If the distribution is symmetric, the skewness will be zero. A right-skewed distribution has a positive skewness. Income and wealth are examples of right-skewed distributions. Most people earn a modest amount, but some millionaires and billionaires extend the right tail into very high values. The hourly wage distribution in this example is right-skewed. The summarize command with the detail option gives its skewness coefficient of 1.33. Kurtosis is another measure of the variable's distribution. The smaller the kurtosis, the flatter the distribution and the thicker the tails are. The normal distribution has a kurtosis of 3. We can also use the inspect command followed by the variable's name. We see that all wages are positive. There's no missing value. We see a very rough histogram that tells us a lot of the data are on the left-hand side, and there is a tail on the right-hand side. It tells us the hourly wage is not normally distributed. Stata can perform a test for normality based on skewness and kurtosis using the sktest command, followed by the variable's name. The null hypothesis is that the variable is normally distributed. The statistic of 0 indicates that we reject the normality null hypothesis at any reasonable significance level, and conclude that the hourly wage is not normally distributed. Finally, we use the Stata graph command histogram to visualize the data. We type histogram followed by the variable's name, hwage. We see that the hourly wage distribution is right-skewed. The hourly wages for most workers are clustered on the left-hand side, and there is a long tail to the right that represents a small number of workers who earn very high wages. Please refer to my other videos for more information about the Stata graph commands. Thank you very much for watching this video. See you tomorrow on the next topic. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.